Hi everyone, this is Anne. In this video, I'm going to be going over how to write the proof for this sentence right here, or this statement. So the statement says, the negative of any even integer is even. So the first thing you want to do when you are writing a direct proof is turn the statement into its if-then form. So in this case, there is just one variable since it says any even integer. So we could say if n, we could use any letter as the variable, is an even integer, then negative n is even. The negative of any even integer is even. If n is an even integer, then negative n is even. Okay? So now, what we want to do is write the proof. What we want to do now is first write the word suppose or something similar to that. Writing proofs is an art, so there are many ways to write a proof. You don't have to use the word suppose. I just like using it and it works. So suppose, and then you write the if part of the if-then statement. Suppose n is an even integer. Then we want to address all of the definitions that needs to be clarified. So we don't have to write a definition for integer, but we do need to write a definition for even. So here I have the definition of even. It says, an integer n is even if and only if n equals twice some integer. Symbolically, if n is an integer, then n is even when there exists an integer k such that n equals 2k. So what we want to do is say something that addresses that. By the definition of even, n equals 2k, where k is an element of the set of integers. So now, we're going to reuse this definition later on in our proof because we're trying to prove that negative n is even. So we have to say that negative n is in this format somehow because it's even. So we could introduce negative n by saying, then negative n equals negative 2k, since we established that n equals 2k, so negative n equals negative 2k. And then we could rearrange the negative sign. So instead of negative 2k, it could be 2 times negative k. And we know that negative k is an integer because integers are closed under multiplication. Meaning, when we multiply integers together, its product is an integer. When we say closed under subtraction, that means when we subtract integers together, the difference is an integer. When we add integers together, the sum is an integer. Keep in mind, though, that integers are not closed under division, because when we divide integers, that does not always create integers. For example, 1 over 2 is not an integer, 1/2 is not an integer, but 1 is an integer and 2 is an integer. But this is just an example to show that integers are not closed under division, but they are closed under multiplication, addition, and subtraction. So we could also then say, let r equal negative k. This means negative n equals 2r, where r is an integer, which is the definition of even. Because remember, we said that the definition of even is 2 times some integer, and here we're saying negative n equals 2 times some integer, which is the definition of even. The very first sentence of the proof is the if part. The very last sentence of the proof is the then part. So then we could say thus, and then rewrite the then part. Thus, negative n is even. We don't write the if or the then, but we write what comes after it for the first sentence and last sentence. At the very end of each proof, you make some kind of symbol to indicate that your proof is done. The most common symbol is the QED symbol, which is a little square right here. And there we go. That's how you write the proof for this statement.